Okay, simple linear regression. Now we want to use just simultaneous approach. We want to use simultaneous approach to find a regression model. Let's remember we have y equals to beta naught plus beta 1 x. So if I don't want to use a formula, I want to use just maybe I forgot the exact or the correct formula, I can just use simultaneous equation approach to find the value of the parameters of this regression model. Now, we have two parameters here. The first one is beta naught and we have beta 1. The coefficient of beta naught here is 1. So therefore, we just assume it to be summation. So we are going to multiply this model by summation. So we have a summation y equals to, this is a parameter, you cannot submit, this is a constant value, you cannot submit the constant value. Therefore, we have a n beta naught, then we have plus, we have variable here. So you can say this is a beta 1 summation x. So let's say this is equation 1. Now, for the other parameter, which is beta 1 here, this one has variable which is x, so it means we're going to multiply the whole of this equation by summation x. So we have summation x multiplied by y. We have a summation xy equals to beta naught multiplied summation x. We have a beta naught summation x plus summation x times summation x. We have a beta 1 summation x raised to the power of 2. So we have an equation 2. You can see we're able to derive two equations from this model because we have two unknown variables, which is the two parameters. So two parameters, two equations. We can just use simultaneous equation to um, to find the parameters of the model. Now let's consider this data below. Consider the data below. We're going to use this data as example just to show you how to use simultaneous to find the two parameters. So here we have x and we have y. So x1, 3, 4, 7, 8. We have y to be 5, 3, 7, 9, and 10. Alright. So from this now, let's formulate a table because we need summation x, we need summation y, we need summation x squared, and we need summation x squared, and we need summation x, y. So yeah, so this is our x, which is a 1, 3, 4, 7, 8. And we have y, which is a 5, 3, 7, 9, 10. 7, 9, 10. So first we have summation x equals to 1 plus 3 plus 4 plus 7 plus 8. That is 23, comma. Summation y equals to 5 plus 3 plus 7 plus 9 plus 10. That is 34. So next we need xy table. So this is xy. Multiply this column by this column. Each value here multiply by corresponding value here. 1 times 5 will give us 5. 3 times 3, that is 9. 4 times 7, 28. 7 times 9, 63. 8 times 10, we have 80. So if you add all of this together, 5 plus 9 plus 28 plus 63 plus 18, we have a summation xy will be equals to 185. Then we need a summation x squared. Right from here, we need x squared. So x squared. Each value in the column of x, we are going to square it. We have 1 square 1, 3 square, that is 9, 4 square 16, 7 square we have 49, and 8 square we have 64. We got these from this column. So if you add all of this together, 10 plus 16 plus 49 plus 64, that is 139. 129. And how many what was it called, observation we have in each variable? We have 5 observation. So which means our n, that is the number of observation in each variable, is 5. So we have 5. Now we can substitute this summation into this equation here. So what do we have? So we have summation y from here is 34. So we have 34 equals to n is 5. We have n beta naught, that is 5 beta naught, plus beta 1 summation x. Our summation x is 23. So we have 23 beta 1. This is really equation 1 now. Now for equation 2, we have summation xy. Summation xy is 185. 185 equals to summation x will still remain 23. So we have a 23 beta naught plus summation x squared, which is 139. So we have a 139 beta 1. This is equation 2. Now we can make beta naught the subject from any of this equation, either from equation 1 or equation 2. So now let's make beta naught the subject from equation 1. We'll just say from equation 1, I want to make this beta naught the subject. So we're going to have beta naught to be equals to, if you take 23 beta 1 to the other side, we're going to have 34 minus 23 beta 1, then divided by the coefficient of beta naught, which is 5. So that is our beta naught. We can just say this one to be equation 3. Let's make it equation 3. Now substitute, let's substitute equation 3 into equation 2. We want to substitute this equation 3 into our equation 2, and our equation 2 started with 185. So we have 185 equals to 23. Now we have 23 beta naught. So our beta naught now is 34 minus 23 beta 1, all divided by 5. Then we have plus 139 beta 1. We have 139 beta 1. So what do we do? We can open this bracket with this 23. So therefore we have 185 to be equals to, we have 23 multiplied by 34. If you press your calculator, we have 23 multiplied by 34. That is 782 minus, we have 23 multiplied by 23. That should be 529 beta 1. Still, we have it as divided by 5. You cannot multiply 23 by 5 because the denominator here is 1. So 1 multiplied by 5 will give you 5. Then we have a plus 139 beta 1. 139 beta 1. So if you want to get rid of this denominator here, we can just, okay, before then, let's take the LCM here. By the time we take the LCM here, then we'll know the exact thing we're doing. So we have 185, or just said 5 multiplied by 185. 5 multiplied by 185 will give us, let me cancel this, we have 925 equals to, if you pick the LCM, we have 782 minus 529 beta 1 plus this 5 multiplied by 139, that is going to be 695 beta 1. You're supposed to have divided by, but we've already used it to multiply the value at the other end here. So now 782, if you take it out, so we have 925 minus 782. If you take this one out, so what will remain is 143 equals to, then we have minus 529 beta 1 plus 695 beta 1. So if you add it together, we are going to have 166 beta 1. Make beta 1 the subject here. So we have beta 1 equals to 143 divided by 166. So therefore, beta 1, if you divide it correctly, it's going to give you 0.8614. So out of the two parameter, we are able to get the first value of beta 1. We've gotten the value for beta 1. That is one of the two parameters. So now we can now come back to this equation 3. So what do? We substitute 0.8614 for beta 1 in equation 3. We're going to substitute this value for beta 1 in equation 3. Therefore, we have beta naught to be equals to 34 minus 23 into bracket beta 1. And our beta 1 right from here gives us 0.8614. Then we have all divided by 5. So you have beta naught 9 to be equals to 34 minus 23 times 0.8614. If you multiply it, that is this minus the multiplication of this value, we're going to have 14.1878 divided by 5. We have it as divided by 5. Therefore, we have a beta naught to be equals to 40.1878 divided by 5. That will give us 2.8376. So this is the value for our beta 1, and we have this value for our beta naught. So coming back to this model, which is a y equals to beta naught plus beta 1x, we have a y equals to the value of beta naught, which is 2.8376 plus beta 1, which is 0.8614x. So now if you want to predict, let's assume that this is year 1, year 2, year 3, year 4, year 5. If by year 6 the value of x is 12, what do you do to predict the value of y? You just make it to be y equals to, it's bad, y equals to 2.8376 plus 0.8614 into bracket 12. So whatever value you get here is going to give you what you're going to get as corresponding value of y.